Hi everyone, welcome to this lesson. Do you know there's a feature on S1 to help us design our own automatic aiming system? Well, in this lesson, I'm going to explain to you how to implement an object tracking on S1. To achieve accurate object tracking, we need to learn three important things. The first thing is automatic control system. The second thing is what is PID controller? And the last thing is how to implement the PID controller in Scratch programming. When a visual marker comes into the viewport of the robot's gimbal will quickly aim at the center of the visual marker while launching a gel bead. Do you know how it's realized? When the marker is moving in the viewport, the robot's gimbal will first follow it. So let's say if this is the viewport of S1, which is the area the S1 can actually see from the camera, and let's say the visual marker is over here. And here's the center of the viewport. So actually we need to use the PID controller to move the gimbal to eliminate the error between the position of visual marker and the center of the viewport. Let's say this is the positive X direction, and this is the positive Y direction, and this is the origin, 0, 0, and this corner has coordinate 1, 1. So since this is the center of the viewport, the coordinate of it is 0.5, 0.5. And since we don't know the position of this visual marker, let's say the coordinate of this visual marker is x, y. So since we want to put this visual marker in the center of the viewport, obviously this is the error we want to eliminate. And we can decompose it into x direction and y direction. Therefore, the error in x direction equals to 0.5 minus x, and the error in y direction equals to 0.5 minus y. Like I mentioned before, we use PID controller to eliminate the errors over here. So PID controllers are now being widely used in modern control systems. Before we understanding what the PID controller is, we need to learn some concepts of the control system, which can be either closed loop or open loop. The purpose of building a control system is to regulate the output. In an open loop system, the input is not affected by the output. In our daily life, gas stove and a pot form a typical open loop system. When we turn on the valve of the gas stove to produce flame, we start to heat the pot. So in this example, the input is the angle of rotation of the valve, and obviously the controller is the valve itself. The control variable is the flame, and the control object is the pot, and the final output is the temperature of the pot. In this open loop system, there is no feedback from the output value, so we also call this system a non-feedback control system. The advantage of this open loop control system is it has simple structure and very low cost. Let's take a look at the closed loop control system. Here's a diagram for the typical closed loop control system. Different from open loop control system, there's a sensor over here, and it provides a signal path and forms a feedback loop. So it's also called a feedback control system. Now let's go back to the gas stove example. If we introduce a temperature sensor into this system, and it can detect the temperature of the pot and provide it as a feedback to the system, it allows the stove itself to adjust the angle of valve to ensure the temperature of the pot doesn't go too high or too low. Since the closed-loop control system has a feedback loop, it is structurally expensive and complex. As long as the output value deviates from the desired value, a corresponding control variable will be generated to eliminate the error. Now we understand what the control system is. And next, we should learn something about the PID controller normally used in the control system. Let's go back to the object tracking example at the very beginning. The PID controller used in this system is responsible for eliminating the error distance, which is over here, and output the rotational speed of the motors of S1. There are two PID controllers governing the motion of gimbal, one for pitch motor, another one for yaw motor. Actually, PID controllers are not only used in robot control systems, but also found in many other applications such as smart refrigerators or hoverboards. So for the example of object tracking, we need to know how the PID controller eliminates the error on x-axis. So first of all, we need to draw a graph of speed versus the time. So this speed is actually the rotational speed of the motor on your axis. I'll use a solid line to represent the actual speed, omega A, and I'll use dashed line to represent the target speed, or desired speed, omega D. PID controller can calculate three different outputs, P out, I out, and D out. Let's take a look at the P out first. P control, or proportional control, is one of the most frequently used control strategy in feedback control system. P denotes proportional, and the output under this case is output equals to Kp times error. Here, Kp is the scale coefficient. And error is the difference between the actual value and the target value. So in this case, it's omega A minus omega D. So we call it proportional control because the final output is proportional to the error if the Kp is fixed. And the greater the error is, the greater the output will be. In this project, when the center of viewport is approaching to the desired position, which is the center of the visual marker, the error distance is actually decreasing. And at the same time, the rotational speed of motor is dropping as well. During this process, the function of P control is to amplify the error and convert it into the output of rotational speed. Great, it's time to do some programming. The following program allows gimbal to track the visual marker. Let's first take a look at how the program works, and then I will explain the program in detail. If we increase the Kp parameter, the gimbal will rotate faster, so that the center of the field of view of the camera will track the visual marker. Now let's do a very quick recap of today's lesson. First of all, we learn what the control system is. And we know there are two types of control systems, and they are closed-loop control system and open-loop control system. Sometimes they are called feedback control system and non-feedback control system. Then we know what the PID controller is based on this project. We know how P control or proportional control in this project, and in the end, we implement the PID controller in the Scratch programming. This is all for today's lesson. In the next video, I'm going to show you how to implement I control and D control. Right, see you next time.